to solve this kind of solution. So you guys should pay attention to that when you try to use this so-called geometrical method. You must remember that you have give the ratio, right? You will use some lengths to denote some newtons, right? I think I have give an example like we can use 10 millimeters, right? 10 millimeters to denote like 10 kilonewtons. So it's very hard to use my mouse to write something on the screen. So when you finish your so-called false polygon, so if you try to figure out what's the magnitude of FA, you just need to have its length of FA. Maybe its length is 22.4 millimeters per, times your ratio here, you will find actually its real magnitude is 22.4 kilonewtons, right? That tell us how to use geometric method. But actually we do not use this method very often. In most cases, we will use so-called analytical method, right? So today we'll continue to do some examples and then we'll move to new sections. So in this example, we are talking about our analytical method to find plane concurrent force system. Let's say you guys please see this picture. We have 4 forces here, which we know is magnitude like F1, F2, F3, F4, and its orientation. You see, every force in this coordinate system, it has a known angle with one of the axis, maybe x-axis, maybe y-axis. So our task is use the theoretical or analytical method to find or determine the reluctant force of this concurrent force system, right? So we should use that projection method. So please, you guys do this with me together. I will try to explain this very slowly. I hope you guys can totally grasp this method. You see, actually, we know actually we are reluctant force will be Fr, maybe I can write it here. Fr is very hard to use. There's some problem of my computer. I cannot use my PowerPoint. So I cannot use my pen. Actually, I have this pen. You guys cannot see. It's a pen. It can write something in the screen on the screen, but it cannot be used here. So actually, we know the resultant force Fr will equals Frx along x direction, right? And the other component will be Fry along y-axis, right? So it's a typical vector. So all we have to do is we should use this method to find Frx and Fry respectively. So because this is a very simple force system, we only have 4 forces. So we only need to projection each force onto x-axis and plus its component accordingly, then we will find its Frx. So you can see, actually we have Frx equals sigma Fix. That means we should project each force onto x-axis, right? But when we try to do some projection, we should first know its magnitude. The second is intersect angle. And second, that is very important. You should figure out its projection force, its direction. If that direction is along the positive direction of x, then it will have a positive sign. And if some force like F second here, so when we do the projection, we will find actually its component FR, F second x, will along the negative direction of x. So we will have give a minus sign here. So that's the very important thing you guys should pay attention to, right? Because the first magnitude, the second direction is all known to us, right? So let's do it together. So first step, we should find FRX. We know it equals sum of each FIX. That means we should do the projection from F1, F2, F3, and F4, right? So please, you guys pay attention to this figure. We have F1, and we have this intersect angle with 30 degrees. So we do the projection method. We just imagine that we should try to do this normal projection, right? So this F1x will equal F1 times cosine 30, right? This whole length of here, right? Actually, this is F1x. And the most important thing is we find actually this projection, when we get its F1x, its direction is along the positive direction of x. Agree that? Am I say that clear? So this one, F1 times cosine 30 will be the magnitude of what F1x, and its direction is along the positive direction of x. So it has the positive sign. So when you need to write a positive sign, you can just do not write it because it just means a +1, right? So we do not need to write it. So use the same step. Then we should consider F second. You guys, you will find actually F second have a go with the left part of x. So once again, we do the normal projection onto here, right? Actually, this part, this length will denote the magnitude of F second x, right? And you will see, you will find actually this time F second x, maybe F second x, its direction will along with negative direction of x, right? So we have given minus sign here. This is very important. Figure out these correctly, then your result may be not correct, right? So we have its magnitude is F second times cosine 60, and then we should give the minus sign, right? So let's consider this absurd together. So we also know there is another intersect angle 45 degree with this left part of x-axis. So once again, when we do this normal projection, see, we will find actually this length will denote the magnitude of absurd x, right? And its magnitude will be f third times cosine 45. And once again, we find its direction is along with the negative direction of x. So we also should give a minus sign here, and this is magnitude. And the final one, we have F4. So you find actually it has an intersect angle 45 degree with the positive part of x-axis. And we do the projection, we will find f4x. Its magnitude will be f4 times cosine 45. And because its sign, its direction will along the positive direction of x. So we give a positive sign here, right? So when you give this four part correctly, the only thing is you should use your MATLAB software or your calculator to find out atoms and then find its final result. So you guys can you okay? So actually, if you can totally understand how we can find FRX, FRY in the same manner. So when we find so y-axis from us and here we find and the actually this one is f2 f second y. Its magnitude will be f second times sine 60, right? And its direction is along y, positive y direction. So it have a positive sign, and this is magnitude. So f3 here, maybe I can do a little bit speedy. So we can find actually here is f3(1). Its magnitude should be f3 times cosine 45, and its direction actually along the negative direction of y-axis. So I have minus sign here, and once again, f4 is f4y. Its magnitude is f4 times cosine 40. I'm sorry, sine. Because this is 45, sine 45 actually equal cosine 45, right? But we usually we will always use sine to find FIY. So we have F4 times sine 45 with this part, and its sine also along negative direction of y. So we have another negative sign here. So this four part actually is each false projection onto y. Maybe it's positive like this and this. Maybe they are negative like this and this. After you give this equation, all you need is use your calculator to find its final result, right? Actually, when we finish these two steps, actually we can find FRX and FRY, right? Actually, it may be positive, it also may be negative. It's totally according to your magnitude and your orientation of all the forces in this force system, right? So actually, this is mathematical knowledge. You guys have learned that because it just have two components of vector. So its whole line is actually the norm more at FR equal this part squared plus this part squared. This is very easy, right? It's very easy. So maybe I can change another color. So if we try to figure out, because this one is positive, so this one also positive, then FR should be in the first corner of this coordinate system, right? If we try to find this theta, just find its direction, and this positive part of x-axis is intersect angle. Cosine theta will just equal frx. It may be positive, maybe negative. You just use your result over its more. This part will always be positive, right? This part will always be positive. So when you find this result, you can use your calculator or your software, whatever, you will find the real angle here, right? And if you want, you also can find its intersecting angle with y. Actually, this is not, in many cases, we only need this is enough. So whatever you need, you can find actually theta equals this one and beta equals this one. You can find actually theta plus beta equal 90 degrees. This example tells us how to use analytical method to find a concurrent force system, to find its resultant force and its magnitude and its direction. So can you guys figure out what does a resultant force mean? So I think you guys should pay attention to its important concept. So actually, this concurrent force system have 4 forces from F1 to F4, right? But we can use this so-called analytical method to just find a single FR, it with a given magnitude and a given direction. So the relationship between this resultant force and this original force system is they have same effect to the body or the body system. Can you guys understand me? That means this resultant force will have the same effect to the body or the body system. So when we use this maybe geometric method, maybe analytical method, find its resultant force. Actually, we do a kind of reduction, right? We do some simplified because this time we only need to consider just one single force. Its effect to a body or body system will just equal all of maybe many of concurrent forces effect, right? So you guys will find that use this method, we can find any concurrent force system. Whatever atoms it has, maybe it had 10 forces, maybe it had 20 forces, whatever the number is, we can use the same method. Actually, we always can simplify that force system into just a single force FR with its magnitude and its direction. So we only need to figure out this FR, its effect to the body or body system is enough. So this is kind of reduction, right? It's kind of simplification or kind of reduction. That's why we should learn this method, right? I hope you guys can understand that. So let's continue. So we'll consider a pretty complex system. Let's see, you guys can just say this this figure. So what we know is the system is shown in this figure, and the weight of the road, the weight of the road and the wheels are not counted. And the size of the pulley is ignored. So this one tells us actually the radius of the pulley is not important. It can bigger, it can smaller, maybe it can only the same size of this pin. It has no effect of our final result. So when you guys find some known condition, it tells us the weight of the road and the wheels are not counted. you should immediately think about maybe some roads are two-force balanced road. In China, we call that 二力杆. Do you guys still have that impression? Actually, we have talked about this. Because if we think that one of the body, like AB and BC here, because their weight are not counted, then actually AB and BC will be 二力杆, two-force balanced road. What means a two-force rod? Because we know it only have two force acted on it, and these two force must have same magnitude and opposite direction and collinear along the link line of these 2 points. So like I can draw here, maybe like BC. So can you guys understand that? So from this picture, from this known condition, because it tells us the weight of the road can be are not counted. So we will find actually this BC will be a two-force balanced road. Then it will only have two force here. We can denote that with FB and FC. Then this FB and FC will have same magnitude, opposite direction, collinear, and at this link line of C and B. So you see, when you find some road in the 二力杆, it will have 4 characteristics. It will help us to find the final answer to us. So it's a great hint to us. So like it. So just along orientation of AB, actually AB also is a double force balanced link. So because this weight P through this rope or string along this pulley and this pulley, so we can see maybe this two force road will be like this. It will be to let you guys find different from this FB and this FB. So I write here FAB, right? This will another FAB. So this is very, very important because from the known condition, we can find actually this rod AB and this rod BC are two double force balanced rod. And we can find actually FAB will along this direction, FBC will along this direction. So all we need to do is, it tells this system is in balance. And that means in condition of equilibrium. So it let us find actions on rows AB and BC. Actually, we actually can the direction of FAB and the direction of FBC. Just because these two rods are two double force balanced rods, but we also need to find its magnitude. So you can see this is a pretty complex system. The whole system is in condition of balanced or in the condition of equilibrium. Then when we just take some part of this as an object to be studied, it all should in the condition of equilibrium, right? So if we try to solve this system, we will think this point of this trolley to be an object to study. So we think that that pin is fixed with this pulley. So actually, when you think, we just consider the action and reaction force point of view. If AB have this, rod AB have this force, then it will be acted by this pin. So from the point, from action and reaction point of view, actually it will have opposite direction with FAB. So I will write in FAB prime. Can you guys understand? Actually, this FAB prime is a pair of action and reaction force with this one. Maybe I change a very good color, maybe right out here. So another is, so if this BC is another double force balanced rod, if it acted by a force FB at point B, then actually will be acted by this pin. So once again, from action and reaction point of view, then this BC actually from point B will give a reaction force to heat. So I can write it as FB prime. You see? So actually, when we think we cut this ring and this ring out, because this is tension constraint, do you guys still remember? We always said this kind of string always pull, never push. So it will have this. FT here means tension force, and here. So actually this FT is equal P. Do you guys know why? Why FT always equal P? Actually, you can just select this one to be an object to start it, because the whole system is in balance. Then any system will be in balance. So actually, if here is a gravitational force P, then this FT must have same magnitude, opposite direction, collinear with P. So FT will totally equal P, right? So actually, this is the force analysis to this pulley. Our task to find real magnitude of FAB prime and FP prime. But there another condition we do not use it in that. You see, the size of the pulley is ignored. So actually the size use this radius. So I draw a little circle here. So if it tells the size of the pulley is ignored, so we can think its radius will be 0, will be just small enough equal to this pin. So actually our finished select this point or this pin or this node to be started. Our force analysis change into this. So here F1, F second actually is Ft and Ft. So F1 and F second will always equal P equal 20 kilonewtons, and along minus y-axis direction and minus x axis direction. You see? So actually, after all this, we have this and this. So you guys will find actually we find or we get another concurrent force system. So please, you guys, for our simple calculation, so we give this reference coordinate system with x point to this direction and y point to this direction, just to easy our calculation precise. So if some guy maybe one of you, let's say B001, right? You will say, actually, teacher, I always like to use the default system direction of coordinate system. I always like x positive to right and y positive to up, right? It's okay. It's okay. You can find the totally equal results. So you guys can try that. I will not do that here today. So we just use this. So you will find actually there are 1, 2, 3, 4 forces, right? Our task is to find the magnitudes of FBC and FBA. So actually from analytical method to find, because this force system is in the condition of equilibrium. So we have actually a concurrent force system. Its equilibrium condition is Frx equals 0, right? Its equilibrium condition is Frx equals 0 and Fry equals 0. So actually this means two equations. One equation can solve one unknowns. So if this is a concurrent force system, and we have two equations to denote its equilibrium condition. So the total unknown we can find is 2. So you guys can find actually F1, F2, we know its magnitude, we know its direction. FBC and FBA, we know its direction, but these two magnitudes we don't know. So we can just use two equations to find FBC and FBA. And after we finish that, we can, from action and reaction point of view, we can find actually reaction FBC prime and FBA prime here. See? So until now, we can just use these two equations. So when we write Frx means sigma Fx equals 0. So once again, we should do the projection precise, right? So let us do that together. So when we write sigma Fx equals 0, we should according our coordinate system. So we try to project all the forces of this system onto X. So we find FBA actually is on the negative direction of X. So it just need to write minus FBA, just because the direction of FBA is along the negative direction of X, right? And FBC, you will find its direction is perpendicular to X axis. So its projection onto X will have 0. So actually we do not need to consider this FBC. And F1. So we have this angle, 30. So maybe you guys need your time to find why this is 30 and why this is 60. We come back to here because this is 30 and this should be 30. You can see we just to smaller this radius of this pulley because it set up the pulley is ignored. Then this point will move to this point. Then it's vertical downward here, its angle will be 30, and this one will be also have 60, right? So we do F1 cosine 30. Actually, this one will along y-axis. So we have F1 times sine 6. Maybe it will confusing you guys if this angle is 30. So we can say actually this angle will be 60, right? So we can use projection. You just need to find F1x. So you will find F1x its magnitude will be F1 times cosine 30, and its direction actually along the positive direction of x. So we have this part. And once again, if this intersect angle is 60, then this angle will be 30. So we have Fr times cosine, F second times cosine 30. And it have a negative direction. So we have minus here. You see, actually from this equation, this part are all known conditions. So we can easily find actually a result of FBA. see? And if we give another condition, sigma Fy equals 0, so we should once again, because FBC, it is on the y-axis and along positive direction. So we write FBC here, and F1, it can times cosine 30 along negative direction. So we have minus F1 cosine 30, and because FBA perpendicular to y, so we do not need to consider that. We only need the final one, F second. So we have F second times cosine 60, once again, along negative direction of y. So we have minus F second cosine 60 equal 0. And F1 equal F second equal P equal 20 kilonewtons, right? So we can finally find this one. So see, can you guys totally understand this example? Do you guys think this example is very difficult to understand? What about you? Can you guys understand?
Yes, I understand.
Okay, that's great. So then we can move on, right? Since you guys can totally understand these two examples, so we only have maybe 15 minutes, we will move to the new section of this chapter. So we'll continue to talk about the resultant and equilibrium of couple and the moment of a couple. So this couple, I think in English, maybe it means 2, 1, 2, right? The way describe a wife and husband, maybe we should use this couple, right? Actually, couple here in our course here in Chinese, we call that. I have one question also in previous part. So number 14, what's question? Can you speak out? Maybe you can write your question in our WeChat. Why we use always cosine ratio? Okay, I come back to here. Actually, we do not need to always use cosine, right? I'm sorry, number 14. How should I read your header? Can I use your name header? Maybe I just use a part of your name, right? Number 14, header, okay? Actually, it not means we always use cosine. We can use sine, right? Just for what it only we can find the result is fine. You see, I can give you example. So F1, actually we know it intersects angle 30 here. Actually here, if you can figure out F1 times cosine 30 will be its y component. Actually, we can also use F1 times sine 30. It will be its x component, right? So actually you can write F1 times sine 30. It's fine. It's totally up to you. If you can, because these two angle, its sum always 90 degree, right? You can select whatever you like angle. You just got the right magnitude and right direction is fine, right? So you can use actually this plus F1 times sine 30, or you can use plus F1 times cosine 60. You see, this one is equal. It not means we should always use cosine. Actually, it's totally up to us. So you can just find either way to get your final result, right? That my answer. I hope you can understand that, right? Okay, okay. Thank you, Heather. So we will continue to talk about couple and moment of couple. Here it's not mean wife and husband. Actually, in China we call that 利偶. So 利偶 means a pair of forces, right? There are two forces. So you can see this simple figure. Actually, we call that 利 means there are two forces. One force is F1 and another is F2. And their relationship is very typical. So you will find actually this so-called couple is two forces F1 and F2. It has they have some characteristics. One, you will find F1 and F2 will have same magnitude and opposite direction and perpendicular one to each other. That means if we see this line AC is action line of F1, and this one maybe BD is action line of F2. Actually, this AC and this BD is always parallel to each other. You see, that are the characteristic of a couple. We call that Leo. And then we have another very important concept of moment of couple. So actually, this F1 and this second, this pair of force will have effect. It will try to let a given body to rotate around some axis, right? So it will have a rotational effect to a body system. That effect is because of moment of a couple. Actually, we use in Chinese that 利有句. So you guys can think about the moment of a point to a force to a point. That means 利有句. Actually, we have learned the moment of force to a point. Let's say if I give you a force F here, and this maybe use AB. So if we have a coordinate system, actually we have learned this as the first chapter. You guys, you have impression. So if we link OA, because this A denotes the point of action of this force, because a force have three factors. One is magnitude, another is direction, the third is point of action. Actually, because in our course this semester, all the body are counted as rigid body. So it can be changed into line of action, right? So when link this OA, we have a position vector. You guys still remember? So actually we have the moment of force F to this point O, we use this MOF equal R vector cross product F vector. So we have learned that moment of a force to a point actually is the cross product of two vectors. So this moment is always another vector. So that vector will perpendicular to the plane constituted by this R and this F, right? So that force is moment to a point. So here we are talking about the moment of a couple. Actually, this moment is by two forces, right? So it will have some relationship between this moment to that moment. So the same relationship is the biggest relationship is their effect to a body system is the same. they all try to let that body or that body system to do some rotational movement, right? Let us know how to get the moment of a couple about a point. So you can see, actually, if we have a couple here, actually, this is the plane of this couple. In Chinese, we call that 作用面. So actually, point of a couple is meaningless. So plane of the couple is useful, you know? So if we, I have said the three factors of a force is magnitude, direction, and point of action. Then three vectors of couple may be one of is the plane of the couple. The other two will be also magnitude and direction. Actually, there also have a big factor is the distance between these two action lines, because this action line always parallel to this action line. So a parallel line will have a distance. We use d. So actually, we have from mathematical point of view, if we try to figure out the moment of this couple about a point O, actually we should give a position vector ROB here, you know, position vector ROA here. Actually, this action point of this F and this action point of this F. So we need link B and A, and the direction also from B to A. So we have another vector RBA, right? So you guys can find actually from mathematical point of view, MO actually equal RAB cross product F, right? Also a two vectors cross product. Actually, you can find actually this RBA, ROB plus RBA equal ROA. So actually this RAB equals ROA minus ROB. Actually, from the geometrical meaning of cross products, I'm not sure if you guys still have that impression. Actually, this one equal norm of RAB and norm of F vector, and its sine angle, maybe theta, between this one and this one. So that means if let's say this angle is theta, so actually RBA cross product F actually equals this magnitude AB times this magnitude F times sine theta. So if I link this one, actually we have a sign principle of how to find the area of triangle. 三角形面积的正弦定理. So actually it's equal 2 times S, actual area of this triangle. You know? So actually, if we try to find the area of this triangle, we only need to know its D. So that means we should draw a perpendicular line from B to this action line. So this length will equal D. So actually, we can find this 2 times area of this triangle actually equals 2 times F times D, right? So that's how we use this easy one. We always do not use this cross product because it's very complicated, right? So we just need to use this 2 times F times D. So that is how we find the moment of a couple about a point. So actually this, if we know this point O, actually MO equal positive or minus F times D. This positive or our manners means is different direction. I think it's time for us to have a short break. We will restart at 11:10. Okay, so you guys have a rest.
对，老师。
OK，
OK，老师。
好的，好的。 Okay, guys, I think our time is up, so we'll continue to talk about this. This page actually tells us how to figure out its direction of a moment of a couple about the point. So actually, we have this conclusion. When we know this f and distance from this two action line, then we have its magnitude of this moment will just f times d. So how to think about this positive manners? Actually, it tells us the sign of the moment. So please, you guys, there are two methods of us to find to figure out the direction of the moment. So one is, please, you guys pay attention to my description. So you can think, actually, your eye to look down onto the plane of the couple. See? So if you find actually this couple is along counterclockwise rotation, it will be plus. And once again, if you just use your eyes look down onto the plane of the couple, you'll find that couple is along clockwise rotation, then it will be minus. It will be minus sign. So why is this? Actually, we also can use right hand rule. Do you guys still remember? Actually, we always use this so-called right hand rule. 右手定则 right hand. It's hard for me to write things on this screen. I'm sorry. Right hand rule. R-U-L-E. 右手定则. So we just need to use our right hand. So the first step, we should let our four fingers along this. Maybe this, or maybe this, maybe along this distance, right? And the second step is you folding your forefinger, like four fingers along one of your F, maybe F, maybe F prime, right? So just to see the left finger, if always first we use our four fingers along this link line, right? Second, we should let our four fingers folding along F direction or F prime direction. Whatever direction you select, you will find actually your thumb will point out of this plane. Oh, actually, if you guys know the definition of a normal line of the plane, so actually this normal line direction, then you will find it's positive. So next time, maybe if I draw another one for you guys. So if we find actually this one and this one, if this is F and this is F prime. So actually, if you look down at this plane, you will find actually this couple is along clockwise direction, right? We also can use the right hand rule again. So first, let our four fingers along this link line. Then select one of the fours, F or F prime. Just let your folding your four fingers, let that four fingers along with direction of F or the direction of F prime. So whichever you select, you will find actually this time our thumb is try to push into the plane. Actually, that direction is negative direction of the normal line of this plane. See? So that will be negative. We use minus sign. So let me give you a very simple example. Maybe you guys study a long time and you feel you very thirsty and you have a bottle of water, you want to drink it. See? So when you have maybe when you have your bottle of water, you see, you try to open the lid. Am I right? The lid, guys, right? You can find you have to use clockwise rotation to rotate your lid. Then you can open it, right? So this is positive direction. But if you don't, if you are not that thirsty, maybe you cannot finish all the water in your bottle, maybe. So you will close it to try to use next time. Then this time we will use, you see, I rotate this lid, let it rotate along clockwise rotation, clockwise direction, right? So this time it closed again. See, these two opposites direction actually, one is positive, another is negative. Do you guys understand? So that is how
Yes,
we
Raj.
find or figure out its direction. Okay, so let's move on. There are very important things we should know when we talk about equilibrium conditions and important characteristics of a couple. So you guys pay attention to here. So some important characteristics of a couple are as follows. There are three of them. So one is a couple has no resultant force. So if we try to find its resultant force, you will find its resultant force is zero. Actually, it's not correct because the resultant force will have the same effect to the original force system. So a couple has no resultant force. So the couple can only be equilibrium to another couple, not a force. That means if we have a body, maybe like this, we know a couple acting on this body, maybe along clockwise direction, we use this M1. So we try to counterbalance it and let this body to be in a state of balance again. So if you try to give them a force, that means to prevent this body rotate along some axis or around some point, you will feel it, always feel it, right? Because we cannot use a force to counterbalance a couple, right? Because the couple's effect is try to let this body rotate around some point or some axis. So can we just use the force to counterbalance them? So that is when a couple has no resultant force. So a couple can only be equilibrium. That means we should try to give another couple another moment to equilibrium this. So the second is the location of a couple in the plane does not influence the rotational effect. You know, the couple have rotational effect. So the couple can be equilibrium moved to any position in its plane or parallel plane, you know? So that means the only figure is the one in the magnitude of F times D. We do not need to figure out what's the real value of F and what's the real value of D. We only need the result of this multiplication, right? Because we can enlarge this D into 2D and we shrink F into a half F, right? Then a half F times 2D will also FD have the same result. So we only, this one is the important factor. Actually, the F and its distance is not important. Another one is direction. So actually, there are no location of a couple, only the plane of the couple, and the plane can be parallel without influence the rotation effect of the couple. So the third is in the plane of a couple, 平面流, changing the magnitude of each force and the perpendicular distance, just as I say here, while keeping the moment scalar of f times d of the same value constant. While keeping the moment scalar of a couple constant does not influence the rotation effect of a couple. So these three characteristics tell us we can only use another couple, maybe f second, have different direction to f m1 to counterbalance its rotation effect to this body, right? So this is the first we should pay attention to. Another is in the plane of couple, changing the magnitude of each force and the perpendicular distance while keeping the moment scalar of the couple constant does not influence the rotation effect of the couple, right? So only these two guesses is multiplication result is important. So this one and that one, maybe we have third of f and 3 times d. Or if they have the real result of f times d, it will have equal or same effect to the body or body system, right? And actually the location of a couple is meaningless. Actually, the plane of the couple is useful, right? That's the very important characteristics of a couple. So let's move on. Let's talk about the resultant of a couple system. So if we have a force system, it's very typical or very special, only have some number of couple. Maybe some of the couple is positive, another is negative. So when we talk about the resultant of a couple system, we only need to do this sum is enough. So it tells us a couple system consists of n, this n means number, couples in which planes may intersect or be parallel with each other. Actually, that means these n couples may be in the same plane. I think not the plane intersect means this plane maybe is just the same plane, or all these planes are parallel with each other, not intersect, right? According to the similar geometric method in accordance with concurrent force system, the resultant of couple system. So what means resultant? It's more simple and it has the same effect to the body system compared to the original system. So that's the resultant of the couple system. So the resultant of couple system is always another couple, and the moment vector of the resultant couple M is equal to vector sum of moment vectors of all couples that form the couple system F1 M second. So you guys will maybe cannot understand why it's so easy, because we see maybe all couple in the same plane, or its action plane is parallel from with each other. So that means all the couples its direction will parallel from one to each other. Can you understand that? So maybe this direction of M second, so maybe this direction of M1. Because it may be positive or it may be negative. So if there are a lot of number of couples in this couple system, maybe this M third, and maybe this M4. So you can see all these vectors of this moment will along the same direction, all the vertical direction, right? So we need to only to think that we have AD, our reference axis, we will projection all these vectors onto this same axis, right? So maybe someone is positive, maybe some others are negative. So we only use this. And then the final result, that is the resultant of the couple system, maybe zero, maybe another single moment. You see? So the further things we will talk about the equilibrium of a couple system. So the only condition is if we found that MR, when we do this sum, this very simple sum, if the final result is zero, then we will find actually this couple system is in the condition of equilibrium. You know? So that's the equilibrium of a couple system. So once again, we can recall the condition of a concurrent force system. So we have that if it is a plane concurrent force system, then its resultant force will equal Fi, should equal 0, right? So that's a condition, that's the equilibrium condition of a force system, a concurrent force system, which can be changed into two scalar equations, that is Frx equals 0, right? And Fry equals 0. Actually, we have used this condition to solve some kind of examples together today, right? And Fry equals 0. So we will find actually the equilibrium condition of a couple system is very simple compared to this one, because it only have one equation, right? Only have one equation. That means if this body system is in this couple system is equilibrium, its rotation effect is 0. Just like there are no any couple exerted on the body or on the body system, right? So let's see, we will from some simple, very simple problem to try to understand the resultant and equilibrium. So actually this part of pages from our textbook, you guys can check this later by yourself if you cannot totally understand what I said here, right? So the dimensions of 4-bar linking are shown here. Actually, we said it is the 4-bar linking, the OA, AB, BD. Actually, this OD is frame that will fix, always fixed, never move, have no any other kind of movement, right? So you see, it tells us that the length of OA is R, and dB is double R, right? And we have this intersect angle with direction of AB have intersect angle with horizontal line is alpha. So it tells us the moment of a couple exerted on bar OA along counterclockwise direction, which is positive, M1 here, right? And the moment of a couple exerted on bar BD, named M second, you see it's clockwise, so it's negative. So the weight of the bars are neglected. So how do you guys think about when we encounter this sentence again? If the known condition tells us the weight of the bars are neglected, you should immediately think about that. Maybe one of the road is a double force balance road, right? So actually we can find AB should be a double force balance road, right? Why? Because we do not consider its weight. So it only have two reaction force at point A and point B. and it will in the state of balanced. So the direction of AB, the two force will be along AB direction. Maybe point to each other, maybe away to each other. Obviously, maybe 两端受压 push together, maybe 两端受拉 pull together each other, right? So you see, as long as AB, maybe I can draw AB here. So from these two moments M1 and M2 here, we think actually AB will be exerted the two forces along the same direction, same line. This FAB and this is another FAB. So because it is a double force balanced load, we always use the same to denote the force. Actually, because these two forces will have what? Have same magnitude, opposite direction, collinear, right? Actually, you just need to find one and you find all the two forces, right? So actually, this FAB is exerted from bar OA to AB. And this FAB actually is bar BD exerted by bar BD to AB, right? So you guys see that when you select OA as an object to be studied, then we should totally consider our action and reaction point of view. So if OA try to pull AB along this direction from pin A, then this AB will pull OA along the opposite direction, right? So we have FAB here. That means it's more, I can draw this here. So FAB and this FAB prime will be a pair of action and reaction force, right? So you guess, actually this point O is constraint type is a fixed constraint. Do you guys remember? I tell you guys you should very familiar with 5 common type of constraint and know how to draw its reaction force, right? Because this is a fixed pin, right? It's very difficult to draw fixed pin. So actually we should draw FOX and FOY, right? But this case, this circumstances is very special. Why? So please pay attention to my description here. Because OA in the state of balanced, right? It's in the state of balance, it's in the condition of equilibrium. And there is the counterclockwise M1 exerted on this OA. And we know this direction of FAB because this M1 only can be counterbalanced by another couple, right? By another couple. So this FO, it always should be along this direction, which is opposite to this FAB. Why? And its magnitude also should equal FAB. Why? Because this couple, this couple M1 only can be counterbalanced by another couple. So we only have FAB and FO. This FO you can think about, it is the resultant force of FOX and FOY. So it has to be in the opposite direction to FAB here. It also has to be the same magnitude of FAB. Why? Because these two guys have to constitute another couple which can counterbalance the M1. Can you guys understand my description? Can you?
Yes, 老师。
Great, great. You can totally understand. That's great because we know a couple only can be counterbalanced by another couple. Since we only have two forces FAB and FO here, so these two gases have to be constitute another couple with. So we know actually FO is magnitude have to equal FAB. Its direction have to opposite to FAB, right? So the same reason we have the same results because this BD is also in the condition of balanced. It has m second exerted along clockwise direction here. So we have this FBA. Actually, it is a pair of action and reaction force from this one to this one, right? So that means this D is another fixed P, but FD also should be along this direction. Its magnitude also should equal FBA because these two gases also have to constitute another couple which have same magnitude to m second and have opposite direction with this m second. Then this m and this m second can be totally counterbalanced and the resultant will be zero, right? So after all this consideration, we can use some equation to find the real result. Let's see. So if you guys can totally understand that so we have M1. Why? Because it is positive. It's counterclockwise direction, right? So because these two gases will constitute another couple that will have opposite direction with M1. So it must be negative, right? So if I draw a line, I try to get its distance D, right? We try to get that D. So we have the information that this is alpha, right? You see, actually this is the same line. So this angle plus this angle will be 90 degrees. Why? Because this is vertical, this is horizontal. Here is 90 degrees. So this one plus this one will be 90. And this is another 90-degree angle. So we can see actually this one also should be alpha, right? So this length of OA is little r, right? So we can see actually the result of D or magnitude of D actually equal R times cosine alpha because this rectangle and this is its length of here. So R times cosine alpha is D. Then times FAB. This is which one we want to calculate its magnitude. And this one is because actually we can find actually this FO and this FAB will constitute a couple with clockwise direction. So once again, we can use our right hand. So just first step, we use four fingers along OA direction. Then we fold our four finger less is four fingers along FAB direction. You will find actually my thumb is point into the plane, right? You will see your folding direction of your four fingers is clockwise direction, right? Is clockwise direction. So it is negative. So you should give a negative minus sign here. See? So when we get this equation, we can find actually what? Actually FAB equal what? F1 over R cosine alpha. right? For the same reason. So once again, you guys see this picture because this m second, it is matters, you see? This equation. And our another couple FBA here and FD here, these two gas have to constitute counterclockwise direction couple, right? I'm sorry. It's very difficult. I hope it can be erased. So I will try again. So we will try to find its D. Right? So it 2R, double R actually is the length of BD. Why this angle is alpha? Can you guys understand? So maybe I will use the original figure here, draw a perpendicular line here. So why this angle is alpha? Why? Can you guys figure out why this angle is alpha? Can you? If anyone can answer my question, why this angle is alpha? Can you guys answer me? I think actually the simple way to prove that why this angle is alpha is we should use the principle of geometrical knowledge, I think. You guess you can find actually here is the angle we know its value is alpha, right? And you guys can find when I draw a line from D perpendicular to AB here, maybe D prime, you will find actually this angle is two sled. This right one is perpendicular to this one. And this vertical one actually is perpendicular to this horizontal one. So if we have two angles, their two sides are perpendicular to each other's according slide, respectively. Then these two guys may be equal. Maybe its sum will be 180 degree, right? I think, especially in China, I think we have that principle from geometrical. I hope you guys know that. Actually, maybe you can use another method to find actually this angle should be alpha. If we know that, then this D will be 2R double R times cosine alpha here, right? So we have 2 double R times cosine alpha times FBA. So minus m second equals 0. So once again, we will have FBA should equal m second over double R, right? Double R times cosine alpha. So actually, this is the condition why FBA equals FAB. Why? Because you can see here, this FAB prime equal FAB. This FAB prime equal FBA. Actually, because this rod AB is the double balanced rod. So FAB prime will have same magnitude, opposite direction, collinear always, right? So that's why this FAB actually equals this FBA, right? So consider all the conditions we can find. Actually, we have m1 should be 2 times m second. Back to the answer. It tells us if the mechanism is in equilibrium, determine the relationship between m1 and m second. See? That's why m1 should be 2 times m second. Otherwise, it cannot be fulfilled the condition that the whole system is in the condition or in equilibrium condition, right? So actually we use the characteristic of a couple. We use these two terms because the couple only can be counterbalanced by another couple. Right? That's why this FO and this FD have to be along some given directions and have to be have the condition its magnitude should be equal to FAB and its magnitude also should be equal FBA. Maybe some of you try to say to me, "Oh, teacher, you are using this characteristic. It's very complicated to understand. Maybe we cannot do that by ourselves." I'll tell you guys, actually, it's okay. It's okay because when we finish our chapter 3rd, we will talk about how to use the equilibrium condition of a generalized force system. This time, actually, we do not use this special case. Actually, we can just draw Fox here, Foy here, and just give a moment equation. Actually, we can use sigma MOF equals 0. Actually, this is equilibrium condition of a general force system. So you guys need to have some patience. We will learn that later. And maybe they are a little bit difficult to understand here. If you can totally understand, that's great. If you cannot, that's fine. Okay, we'll repeat. We will have another very generalized method to finish and to find the final result. Right? I think that's the total thing of this problem. We still have another 10 minutes. Maybe we will have time to see another example. Okay, so let's continue. So actually, this is your homework. Maybe it's time for you guys to try to finish. So you can see actually this one is more like the example we have learned together, the first class of today, right? So this is your homework. And this also is your homework. So, I mean, you can find, okay. Actually, this is our textbook. I think I have sent the book to you guys. You can find actually our exercise here. You see? So this is what this is, right? I'm sorry, for P for the Q exerted. No. Which one is this? This. So I think from page 30. So from page 30, the first, this one is our homework, and this one is the homework, our homework. So please, you guys, you try to finish by yourself, and next time, maybe we will do that together, right? And actually, this is the end of this chapter 2. We still have another 10 minutes. We'll continue to move to chapter 3rd. Actually, my speed is very slow. I think that's the final of this. See, actually, this is you guys' homework today. You can find here, actually, this one is the answer, but I hope you guys can do it by yourself first. Then we'll discuss or learn it together next time. Okay? So that's the end of this chapter 2nd. We will keep to move to chapter 3rd. So although we only have about 10 minutes, I will continue to do some brief introduction of chapter 3rd. In this chapter 3rd, we will talk about reduction and equilibrium of a force system. Actually, you guys can think about, we just finished to learn about reduction and equilibrium of two special force systems. You see, one is the concurrent force system, another is couple system, right? So this time from chapter 3, we'll talk about reduction and equilibrium of a generalized force system. This force system will not that special. It's not special that all the forces are concurrent or intersect at a common point. Or it's not that special force system, only have couples. So that means if we try to do the reduction and the analysis is equilibrium condition of a generalized plane force system, we will try to change this force system into a concurrent force system plus a couple system. So you guys will soon find that our knowledge of chapter 2 is a very important basis of chapter 3, right? So maybe there are 4 sections we'll learn from one to another. The one is changing the line of action of force, right? Changing the line of action of a force. Another one is reduction of a force system in space to a given point. Actually, we will talk about a little bit space force system, but in many cases, very often, our main focus will be plane force system. So if we talk about some force system in space, it's okay. It's just to have impression is enough. And the third section will the discussion of the results of reduction of a force system in space. It's also okay. And the final one, equilibrium equations of a force system and application. You guys can think about actually a plane. Force system in plane actually is a special case in of a force system in space. Actually, so if you can totally understand the so-called force system in space, then the force system in plane, you can totally use it. Actually, the main difference is the equilibrium condition of a force system in space. It will have 6 equations, but when it simply find into just in plane, it will only have 3 equations. So we'll see later, not today. The final one will be equilibrium equations of a force system and their applications. So I think we only have a little time today to talk about changing the line of action of a force. So let's continue. So the first section is tell us how to change the line of action of a force. Why should we change the line of action of a force? Why should we do this? Because maybe we have a more generalized force system, although it is the force system in plane, but not all the force are intersect into a common point. Then we should try to light all the force actually intersect a common point. Then maybe we need to change its action line, right? So let's see, a force acting on a radiated body can be moved parallel to its lines of action to any point of body if we add a couple. You see? Because after changing the line of action of a force, we should always fulfill a condition. What condition? We should never change the original force, its effect to the body, right? So that means maybe you can change a force that is acting on the same body at another line, but we should keep the effect of the original force to the new position of the force have the same effect. So that is our condition. So that's why we should add a couple with a moment equal to the moment of the force about the point to which it is translated, which is called the theorem of translation of a force. 我们把它叫做力的平移定理 ，right？ 力的 theorem can be principle or 定理，力的平移定理或者力的平移原理。平移 means translation. So this translation means we only move this force F, but we do not change its direction and do not change its magnitude. That means translational move, right? We should keep its magnitude and keep its direction. Let's say 力的平移原理或者平移定理。Right? So let's see. You guys pay attention to these three figures. You tell us why we can have this the theorem of translation of force. Let's see. We have a body here. It have a force F acting on point A. We know it is distance. It has distance from point B, which is horizontally left part of B. So we try to move, translational move this force F from point A to point B, but we should keep its effect of force F be seen, right? So its final result will be, you see, at point B, we have the same magnitude and same direction of original force F, but we also have add a couple. This couple actually is the moment of original force F, its moment to be actually MBF. Right? But actually, it tells us if we translational move this force F from A to B, we only to need add what? A couple. It's the couple is at magnitude will equal what? Will equal MBF. That's the moment of this F to point B, right? Actually equal F times D, right? We always should pay attention to its direction. Actually, this direction is counterclockwise. And why is this? Actually, we use the principle. Do you guys still remember we have talked about public common principle of this? Because we can add or subtract a balanced system. So actually, we can add a balanced subforce system. So we have this F prime, which is which have same magnitude and same direction of this F, and this F2 double prime, it have same magnitude of F prime, collinear to F prime, and opposite direction of F prime. So you guys can know actually these two force actually is resultant force will be zero. These two forces are balanced. So we can freely add or subtract from a body a sub-balanced force system without changing its state. So we can add this and then we can just change it because you will very interested find this F And this double prime F will constitute a couple, right? So because F parallel to this F2 prime and have same magnitude and opposite direction. So we can erase this one and use this M to equal this. Because it is couple have no location, only have a plane of action. So it's the same of this. That's the final result. So I think that our time's up. So that's all for today. We have 2 homeworks for you. I hope you guys can finish by yourself, right? And that's all for today. Bye bye. 下课。
OK，拜拜，老师。
再见，再见，下课了。
OK，老师，再见。
好的，好的，再见。
Thank you。
Thank you.